So the next speaker, quite a nice lead into that, is Nicolas Lopez Villalobos. Nicolas is one of New Zealand's foremost quantitative geneticists. He's a professor at Massey, consults widely on genetic development. His talk is the Prototype Economic Index for Selection of Dairy Sheep. Thank you, Nicolas.
Thank you, John. Good afternoon. So my contribution is similar to what we did for the previous vlog, and this is telling you that we need to come and organize this database, and we put all together and we become more efficient. But we started this project as a master thesis for Megan, and is in the case for the flock of Kate and Andy Ganson. So this is my research contribution as a team with Sam Peterson. And also I would like to acknowledge the help of Susan Roy in this, that we will be progressing into this project. So I will explain in few slides where the opportunity as a collaboration with Ag Research is coming into this prototype. So there is the expectation that the industry will be about 2 million animals with a $1 billion industry. So a breeding program has to be put in place to ensure genetic gain, but also in the right direction. So this is a very scientific point of view. It's good to see genetic gain. It's good to see gain more in productivity. So this is the average, the current average of Andy and Cat that by international standards. So for our surprise, we were expecting that this was going to be lower than the international standards. However, it's around 240 liters per animal. So when Megan compared these values to the international, we believe that this flock and the previous flock are to the level. So there is a very good start. When we are thinking where to go, so we can put very deterministic simulation, and we say, well, ensure some genetic gain, and we just focus on one trait, and let's say, in this case, meal yield, and we say, okay, the ewe by the year 2030, we do the right things, and we put a selection scheme, so we will produce genetic gain. But if we are not careful, so we can end up in a bad situation. So we can end up with this ewe, but also we can end up with a similar ewe with 364 kilograms production with less dry matter requirements. Of course, is going to be the feed cost is going to be lower. So always by experience, it's good to do the homework before we go into the breeding programs. By experience, we see that decision taken 10 years ago were wrong, but in genetics 10 years ago is a lot. So we have knowledge, we have scientists, we have a community that we can put this direction of this breeding program for the New Zealand sheep in the right direction. Why believe? So the objective of that was to develop a prototype system of genetic evaluation for dairy sheep in New Zealand. Again, it's a prototype model. So we have a very energetic lady that is putting a lot of energy in recording. So for this exercise, we use very small flock, 123 ewes with a mixed breed. But it was a lot of energy to produce the hair test for milk, fat, protein, lactose, and somatic cell. And we obtain live weights of each ewe 2 or 3 times during the season. So we want to use this information the most as a scientific, but also as a message for the industry. So the farmers are really, really interested in efficiency, not just productivity, it's just also efficiency. So time, labor is quite important for them, profit is quite important for them. So they decided to produce these interesting phenotypes that from the scientific point of view are very interesting. So first let down time, and first let down milking yield. So again, at the large scale is possible now with current technology. So we went into the process, so we use the hair test. So this is an actual example, this is one of the ewes. So we put how many days after lambing the ewe was, and this is milk yield. So you have 4 hair tests specific for this animal. And we use just a standard methodology to produce what could be the lactation curve of this animal. And the integration under the curve is going to give us the total yield. So we standardize the total yield of this ewe and the total was 373 kilograms milk in 150 days. So we repeat that and we were able to obtain the lactation curve for each of the ewes. And what I can see was a lot of variation, so there is a lot of room for persistency. There is a lot of variation to improve dramatically the flock. So we repeat that for fat, protein, lactose, and somatic cell, and we do the same for live weight. Right. This is a lot of information, but I just want to draw the attention how complex can be the genetic evaluation. As Susan said, no. Actually, what we see is what is behind the genetic merit of the animals. So in this information, you see 3 of the founder size or rams, and what you are going to see the pedigree how is falling very well, because the farmers are recording this information. So what are the breeding values of these animals when they don't produce milk? What is the breeding values of these ewes when we don't have information? What are the breeding values of this animal that we miss the records? Okay. So we put, and very important for Andy is, so what could be the breeding values of these young rams that he will have available for selection? What are the ones to be selected? So the genetic evaluation exploit the relationship between the animals. So you can see this pedigree is, at least in paper, is not totally well connected. So you have one ram, another ram, and this only has 1 progeny, 3 progeny over there, but this has a lot of progeny. This is not a full pedigree, it's just for illustration to you. So when Susan will come into this project, we are going to use markers, and we are going to link all the animals in that. So the accuracy of the prediction is going to be much better. So when we look, or we put the individual yields, and this is an example for milk yield, so you will be thinking that maybe this animal will have will be the best animal for milk production, and you will be thinking that maybe this animal in here is not going to be very good. What happened? This animal is in first lactation, and maybe this animal is in the first or fourth lactation. So we have to account for these effects. So we put into a complex model. We produce genetic evaluation for the whole traits, and the farmer is interested in lactation length, yields, fat protein, light weight, somatic cell score, and these two variables, and liter size. So we put in this model, and we adjust for lactation number and deviation from median lambing date, and so on. And of course, we are interested in the animal effects, exploiting the pedigree information. So to achieve this evaluation, we need genetic parameters, and we don't have genetic parameters. But New Zealand stylists always use what we have available, and we use the expertise of Megan, and Megan basically collected a lot of estimation of heritabilities, and in the green you have the estimation of genetic correlation. So this is not New Zealand, or this is not exactly what we don't know this information yet. Okay, and in the blue we have the phenotypic correlation. The importance in that is for those animals that has missing records for one of the traits, exploiting the genetic correlation will help to predict the other traits. So, as I mentioned to you, this is the descriptive statistics, so 122 valid records. When you see the average, you see meal yield 234 kilograms, and you compare these values into the international values, I don't see that flock is with low production. Large variation, so you have in terms of meal, you see you have a ewe that achieve 526 kilograms meal yield. The typical age effects, so I will not spend too much time. So basically, I will take you into the graph. So you have lactation number, and here you have lactation meal yield. As the animal matures, so there is better expression of the genetic potential. And it happened for basically all the traits. So we started with phenotypes, and using this technology, we end up with breeding values. Okay, the following question. So we have breeding values for lactation length, meal, fat, protein, somatic cell score, these traits, milking characteristics, live weight, and liter size. Okay. So as you can see now, you see the picture is slightly different. No? So now you see we are able to produce a ranking of the founders' size. So some of them has to be positive, some of them has to be negative. And the breeding value, so this is for meal yield, the breeding value totally depends on the relationship. So this ram has only one daughter that produced 293, so the breeding value of this ram is +10. Now you can see this ram has two daughters that produce good levels of milk production, but it came one that has produced 148. We have to be careful if this record is maybe this ewe was sick and basically is creating a false breeding value for that. But this is the importance of checking well enough the information. These young ewes also come with positive breeding values. But most important in here is for Andy is now we have breeding values for those rams that he needs to decide which one is going to choose. What I can see in this graph, you have the distribution of breeding values, so meal yield, very, very significant variation. Likewise, for fat, for protein, and also for live weight. So what I can tell you is there is enough variation to select from. Right, now the next step is how to use these breeding values. So we have different traits. So the important question is selection for what? Okay, so as Jack mentioned, we are going to spend a lot of time to define selection for what? What is the breeding objective? Okay, so I can tell you, so we are going to discuss a lot of selection per milk production per animal, milk solid per animal, milk solid per ton of dry matter, profit per animal, how we are going to calculate profit, profit per ton of dry matter, how we are going to include resistance to diseases and to indexes and functional traits. So it's a lot of homework to do before actually deciding those things. So we have used this information. Once we put all this information into a system like SEAL, as Annie was saying, so we have to estimate this information. This model will be available for the industry. It's not really a mystery, so it's just a matter of implementation. So, but we have to put all this information and define breeding objectives and selection index to produce genetic gain in the right direction. We will be facing how to organize the industry to define a selection scheme. We have fantastic technology now with our research and the use of genomic selection to speed dramatically the rate of genetic gain. Right, thank you so much for your attention.